So f of theta equals sine theta is an odd function because the graph has rotational symmetry about the origin. Meaning that if you were to rotate the graph about the origin 180 degrees, or pi radians about the origin, that you would end up with the same original function. So the question is asking, of course, how can we reflect the graph of f of theta equals sine theta to produce the same graph? Well, if we take a look at this, for example, we have, suppose we've got some value of theta here. We see that we go up to the sine curve, and then across we get some value of y right here on the y-axis. If we go a similar distance away from the y-axis on this side, that's negative theta, we see we go down to the sine curve and then across to the y-axis. We don't get the same value of y as we did originally. We actually get a negative y value. So here's some y value. Here is the negative y value. So sine of theta gives you y, sine of negative theta gives you negative y. So that would tell us that sine of negative theta equals negative sine theta. Okay, because sine theta was y, sine of negative theta was negative y. Okay, therefore negative sine theta. Now if we look at it as a double reflection, suppose we take this, we do a reflection in the theta axis first, so it reflects down, so y reflects down to negative y, and then theta gets reflected in the y-axis, so theta becomes negative theta. What ends up happening is we get that double reflection is the same as a rotation of 180 degrees, or pi radians about the origin. So negative sine of negative theta gives us the original function sine theta again. Alright, so we'll take a look at this step by step. So in step 1, we reflect the graph of sine theta in the y-axis. So we're reflecting, so what this maximum here at pi by 2 gets reflected in the y-axis. So it gives us the maximum over here. And this minimum, of course, would follow suit. It gets reflected in the y-axis and becomes a minimum at positive pi by 2. Okay, so the whole graph just gets reflected in the y-axis. Therefore, sine of negative theta is just sine theta reflected in the y-axis. Then, if we reflect the graph of sine theta in the x-axis, then we see that this maximum gets reflected, or the whole graph gets reflected in the theta axis, or the x-axis, and this maximum then comes down to become minimum, and then this minimum flips up and becomes that maximum there. So then negative sine of negative theta is sine of negative theta reflected in the x-axis. Okay, so sine of negative theta, this function here, is the same as this graph here, sine of negative theta. Okay, so it was reflected in the x-axis that we just did. Therefore, the resulting graph, as we can see here, this resulting graph after step 2 is the same as sine theta. Therefore, negative sine of negative theta equals sine theta. Alright, we'll move along now. What I'd like you to do is the table in part H of the Explore the Math in section 7.1 of the textbook, page 389, is basically the same as this. What I'd like you to do is complete all these statements in this table by examining this special triangle and come up with these trig ratios for all of these primary trig functions and the secondary trig functions. Okay, do that now please. Pause the video and come back to check your table. Okay, so now you've done that, we can see that sine of pi by 3 is root 3 over 2, cos of pi by 3 is 1 over 2, and tan of pi by 3 is root 3 over 1. Therefore, all these secondary, or the reciprocal trigonometric functions would just be the reciprocals of these trig ratios. And then for sine of pi by 6, or all the pi by 6 trig functions, we've got 1 over 2, root 3 over 2, and 1 over root 3. And then the reciprocal functions would be 2, 2 over root 3, and root 3. Now I'd like you to compare to see any relationships or any patterns that you may discover there in the table. Notice, of course, that sine of pi by 3 is equal to cosine of pi by 6. Cosine of pi by 3 is equal to sine of pi by 6. We see that the tan of pi by 3 equals the cotangent of pi by 6, and the tangent of pi by 6 equals the cotangent of pi by 3. And if we look at other reciprocal functions, cosecant of pi by 3 equals the secant of pi by 6, and the secant of pi by 3 equals the cosecant of pi by 6. So not just one trig function will give you the same trigonometric ratio, as we can see from this. Okay, so now let's focus on these triangles. We'll start with here, focusing on this angle theta here, angle A. We know that this is the hypotenuse, and the side across from that angle is the opposite, and the side beside it is the adjacent. Okay, so now, of course, the adjacent, opposite, and the hypotenuse. Let's say that this is angle x. Okay, so we're going to let theta equal x. Now, since triangle ABC is a right triangle, and angle C is pi by 2, therefore, angles A plus B, so these two angles, if this is pi by 2, then these two angles also have to add up to pi by 2, because an entire triangle of the interior angles add up to pi. Therefore, angle B has to equal pi by 2 minus angle A. Therefore, angle B is pi by 2 minus x.